In 8.1, I talked about sequences. Now let's talk about a specific type of sequence known as an arithmetic sequence. And all that means is that we have a sequence whose consecutive terms have what we call a common difference, which is just another way of saying that we are adding the same value every single time to get the next term. So in this case, it's pretty clear in this first example what our common difference is. We're adding 2, right? We can say we're adding 2, right? Every single time we're adding 2. So our common difference is 2. That's not too bad at all. Now, I want to actually think about these terms and write them in a slightly different way, because I think it'll help us get a general sense of what's going on with arithmetic sequences. If I look at my first term 3 here, well, that's 3. Now, if I know that I'm adding my common difference, if I start out at just 3, how many times have I added 2? Well, the answer is none. I haven't added 2 yet. It's just 3. So I would say I have 0 instances of 2. I've added 2 0 times. Now, if you look on to the next term, again, this 5 here, well, what have we done here? This time we've started out at 3, but how many times have I added 2? I've added 2 once. And over here, how many times have I added 2? I've added 2 now twice. I've got 2 instances of 2, and you can see where this is going. I've got 3 instances of 2 that I've added. 11 would be me adding 2 to my original value or my initial value of 3 4 times. Now, why am I going through the trouble of rewriting this here? Because I think, again, it gives us a sense of what's going on and allows us to write the general term. Because what's nice about arithmetic sequences is I can add the same difference or the common difference every single time to get the next term, which is all great. But if I then ask you to find the 432nd term in this sequence, who wants to add 2 that many times? Instead, we want to be able to have an efficient way of finding any particular term in that sequence. So we would say a sub n then is what? And this is why I'm drawing on what I've written out here to give me a sense of what my a sub n is. To find any term in that sequence, what am I really doing? I'm starting out with my first term, right, a sub 1, and I'm adding to it what? Well, think about what's going on. Let me just highlight these. What's going on here? When n was equal to 1, I added 2 0 times. When n was equal to 2, for my second term in the series, I added 2 once. When n is 3, I add 2 twice. So you see that the relationship is just n minus 1 times, and in this case now, let me just do a different color for that, my common difference. Right? So I'm adding my common difference n minus 1 times. Right? And so this is what's the nth, known as the nth term for an arithmetic sequence. So what I've written out here is exactly what I have typed out here. Now, full transparency, I actually prefer this general form for the nth term of an arithmetic sequence. And what's nice about the way I have it written here is this is simply saying that I don't have to use a sub 1. I can actually work with any term in the sequence that you give me and kind of anchor it as a starting point. And I just need to find the difference in order between what term I'm trying to find and what term you've given me. And we'll do an example with that in just a second. But let's just get kind of comfortable working with the nth term here. So let's take a look at this particular sequence in number 1. So looking at this here, first off, ask yourself, what is my common difference? Well, the easy way to do that is simply just find the difference between any 2 terms in the sequence, and might as well go with the easiest ones. So to find my common difference, I'm going to say, what's 7/6 minus 1? Well, that's just equal to 1 over 6. Okay, so that's my common difference. And what is my a sub 1? A sub 1 in this case is just 1. So plugging that into the formula that we have here, we're going to say the following. A sub n is equal to a sub 1, which is 1, plus n minus 1 times 1/6. And let's simplify this here. We've got 1 plus 1/6 times n minus 1. So if I distribute that 1/6, that just gives me 1/6 n plus 5/6. Let me just change that. Right? And so this is my a sub n. Now I want to highlight something pretty cool and interesting here. If I were to graph this a sub n as a function, if I were to graph this function, what type of graph would I have? And the answer would be, it would be a line. And if we think of this as a line, then we can actually compare this to slope-intercept form, in which case we now see that our common difference is really the same thing as our slope. It's the rate at which these terms are changing, right? We have the same kind of rise over run, or that common difference, right? So that's going to be a really important idea when we then talk about geometric series and then start thinking about what those graphs would actually look like. Let's try something like number 2 now. Now, number 2 is interesting because this time I'm not giving you the first term in this sequence. And you could take this information here and you could try to find a sub 1. That would be totally legitimate. But I want to kind of encourage you to think about it slightly differently. First, let's try to figure out what is our common difference here. And what I'm going to do is I'm going to actually plug in these values here into this general term. So what we're going to really do is we're going to say, all right, we're going to treat this as our a sub m and this as our a sub n. And we're just doing this just so that we can solve for our common difference. And it doesn't matter. You can actually flip these around and still get the same thing. But if a sub n, so we're going to write this a sub n, in this case is a sub 11, is equal to a sub m, which is a sub 5, plus. Now, what is the difference in order between a sub n and a sub m? What is n minus m? This would be 11 minus 5 times d. Well, let's plug in a sub 11 and a sub 5. So this is 100, this is 190, and this is 6d. And we just basic equation for us to solve. So this negative 90 is equal to 6d, and d is equal to negative 15. So we have our common difference now. So now that we know what our common difference is, and it just kind of check to make sure it makes sense, and it does, right? Our terms are actually decreasing by negative 15, right? We started at 190 and we're now down to 100. So now let's come up with our general term. So a sub n now is equal to, and I can choose either one of these for our a sub m. Again, it doesn't matter, but instead of me having to try to figure out what my first term is, let's just go ahead and use a sub 5. So we're going to say a sub 5 plus n minus 5 times our common difference d, which is negative 15. Okay? So what is the difference in order between our fifth term and whatever term we're trying to find? That's what we're going to need to find our a sub n. So let's plug in a sub 5. Well, a sub 5 is going to be 190. So what we have here is 190 minus 15 times n minus 5. And we clean that up a little bit. What do we have? That's negative 15n. 75 plus 190, that's 265. And there we go. It's a horrible box, but you get the idea. All right.